Hello everyone, welcome to In 5 Minutes. In this video we are going to see the next type of miscellaneous problem. So the question is, prove that integration of 0 to pi by 2 root sin x upon 5 plus 3 cos x the whole raised to 3 by 2 dx is equal to this term. So we have to solve this integration. But if you solve this integration as it is, this might be a very complex integration. So whenever we have a complex integration, we have to use a beta gamma function to solve our integrations. So now if you see, we have the integration limits from 0 to pi and we have the formula of beta function, that is half beta of m plus 1 upon 2 comma n plus 1 upon 2 is equal to integration of 0 to pi by 2 sin x the whole raised to m into cos x the whole raised to n into dx. So this is the basic formula of beta function in terms of sin and cos. But if you see, in the denominator we have 5 plus 3 cos x. We do not have simple cos x term. So we cannot take this part in the numerator and we cannot represent our equation in this format. So we have to do some substitution. But here if you see, we have seen this type of integration wherein we have a plus b cos x and we have sin x in the numerator. Whenever we have this type of equation in integration, we should substitute that tan x by 2 is nothing but some other variable t. X will be 2 tan inverse of t. In this case, sin x is nothing but 2t upon 1 plus t square and cos x is nothing but 1 minus t square upon 1 plus t square. So this is the basic substitution of integration when we have a plus b cos x term in the denominator. We substitute tan x by 2 equal to t. Okay, so this is our basic substitution, and instead of sin x we are going to substitute 2t upon 1 plus t square. So in this case our dx will be 2 tan inverse of t, derivative of tan inverse of t is 1 plus t square dt. Since we are changing the variable, our limits of integration will also get changed. So here we write initial variable which is x and the new variable is t. X is going from 0 to pi. When we put x equal to 0 here, we get t equal to 0. When we put x equal to pi by 2, we will get t equal to 1. When we put x equal to pi, tan of pi by 2 is nothing but infinity. So if you see, our limits of integration from 0 to pi has been converted into 0 to infinity. So our I is integration of 0 to infinity sin x, root of sin x. So root of this term, which can be written as 2 raised to half into t raised to half upon 1 plus t square the whole raised to half into 5 plus 3 cos x. So 5 plus 3 cos x is this term, that is 1 minus t square upon 1 plus t square. Now I am taking the LCM, so I will get 5 plus 5t square plus 3 minus 3t square upon 1 plus t square. So 5 plus 3 is 8 and 5 minus 3 is 2t square upon 1 plus t square. I can take 2 common, then I will get 2 into 4 plus t square upon 1 plus t square. So instead of 5 plus 3 cos x, we have the term 2 into 4 plus t square upon 1 plus t square the whole raised to 3 by 2 into dx. What is dx? Dx is this term, that is 2 upon 1 plus t square dt. So now we will combine all the t term together and all 2's together and all 1 plus t square term together. So from here we have 2 raised to half. So 2 raised to half, and from here we have 2 raised to 3 by 2. So 2 raised to 3 by 2. Integration 0 to infinity. In the denominator we have 1 plus t square the whole raised to half, and this 1 plus t square the whole raised to 3 by 2 will go in the numerator. So we have in the numerator 1 plus t square the whole raised to 3 by 2, and in the denominator we have 1 plus t square the whole raised to half. So when it goes in the numerator, it will be minus half. So 3 minus 1 upon 2 is nothing but 2 upon 2, which will be simply 1 plus t square. And in this denominator we also have 1 plus t square. So this 1 plus t square and 1 plus t square will get cancelled. So we do not have any 1 plus t square term. We have 4 plus t square the whole raised to 3 by 2 term in the denominator, and this 2 will combine with this 2 raised to half, so plus 1, which will be 3 by 2, and this 2 raised to 3 by 2 and this 2 raised to 3 by 2 will again get cancelled, and we are done with this term. We are also done with this term. Only t raised to half is remaining, so t raised to half dt. So this is our new integration.